Example 24 on pipe friction in turbulent flow. A steel pipe with absolute roughness 0.065 mm, 4,200 meters long is to convey oil with kinematic viscosity 5.2 times 10 to the negative 5 square meter per second at 300 liters per second from one reservoir to the other with difference in oil surface elevation of 91 meters. Neglecting minor losses, determine the size of pipe required. So take note that if you have two reservoirs and they are connected with a pipe, if you write energy equation between the two reservoirs, velocity head, negligible, pressure head in the liquid surface in the reservoir, negligible. So the difference in elevation will be the head loss automatic. So try to do that. So therefore, this difference in elevation of 91 meters is the head loss. So first, let's compute for the velocity. 4 times 0.3 over pi times diameter square. So it is 0.38197 over diameter square. Take note that the diameter is in meter here. Then we compute the Reynolds number. Diameter times velocity 0.38197 over d squared. This is the velocity. Over kinematic viscosity 5.2 times 10 to the negative 5. So it is 7,345.58 over d. And let's assume that let's have the head loss, which is 91, and it is F length over diameter velocity head. So 91 equals friction factor, length over diameter, velocity 0.38197 over d square quantity square over 2g, which is 19.62. So 91 times 19.62 divided by quantity 4,200 times 0.38197 square equals F over d to the fifth. So F over d to the fifth equals 2.9136. Therefore, if we extract square root of F, then square root of F is 1.707 d to the 2.5, half of 5, 2.5. Then assume a smooth pipe flow. So 1 over square root of F equals 2 log Re square root of F over 2.51. So 1 over 1.707 diameter to the 2.5 equals 2 log of Reynolds number 7345.58 over d. Then square root of F is 1.707 d to the 2.5 over 2.51. So simplifying the right side, 1 over 1.707 d to the 2.5 equals 2 log of 4995.58 d to the 1.5. D to the 2.5 over d is d to the 1.5. So using the high-tech calculators, solve for d. D is 0.3899 meter. From here, we can solve for f. Square root of f is 1.707.3899 to the 2.5 square. So f is 0.02626. Then the Reynolds number is 7345.58 over 0.3899. So 188, 18,840. Check the thickness of viscous sublayer 14.14, diameter 389.9 mm from here over Reynolds number square root of f. So it is equal to 1.806 mm, which is greater than E, the absolute roughness of steel pipe. So the assumption is correct. Therefore, we accept 389.9 mm as diameter, or let's round up that to 390 mm.